I'm going to talk to you today about using the method of completing the square. This is a method that you can use to solve quadratic equations when factoring is not easy or when it's not possible, because not all quadratic equations can be factored. As such, it often results in solutions that include square roots or even imaginary numbers. But I want you to remember, a quadratic equation is one that's in this form: ax squared plus bx plus c equals 0. Now the premise of this method is that if taking x squared equals r, then x equals plus or minus the square root of r. Remember, when we looked at the equation x squared equals r, the way we solved this was to take the square root of both sides. The square root of x squared gives us x, and this would give us two solutions, one positive, one negative, and then the answer would be whatever the square root of r is. Now, we're going to use this premise for completing the square, except that what we're going to start with is this: x minus q quantity squared equals r. Take the square root of both sides. The square root of x minus q quantity squared is just x minus q. The square root of r is plus or minus the square root of r. So then what we're going to do is add q to both sides of the equation. That gives us x all by itself, and it equals q plus or minus the square root of r. This is essentially the foundation for the method of solving quadratic equations by completing the square. Let's take a look at this first example. We're going to solve this equation by taking the square root of both sides. So first of all, I have a quadratic equation, and on the left-hand side, notice that this can be factored as x plus 5, or x plus 5 quantity squared. What we're going to do at this point is to take the square root of both sides. So the square root of x plus 5 quantity squared is x plus 5, and this equals plus or minus the square root of 2. Always remember, taking the square root of both sides is going to give you two answers, one positive and one negative. Now subtract 5 from both sides, and so here's what we get. X equals negative 5 plus or minus the square root of 2. And that's the solution for x in this particular equation. Let's take a look at another example. In example A, if I look at the left-hand side of the equation, I can factor this as x minus 2 quantity squared. Or x minus 2, x minus 2. This equals negative 2. My next step is to take the square root of both sides. On the left-hand side, I'm just going to get x minus 2. On the right-hand side, I'm going to get plus or minus the square root of negative 2. Now remember, the square root of negative 2 is the same as the square root of negative 1 times the square root of 2. So really, this equals plus or minus, then the square root of negative 1 is I, so plus or minus I square roots of 2. Now what I want to do is on both sides add 2. So I get x equals 2 plus or minus I square roots of 2. Now this is an imaginary number, so this particular equation has solutions that are imaginary numbers. Let's take a look at B. Again, I can simplify this by factoring. I have a perfect square trinomial here. This is 3x plus 4 quantity squared, and this equals 6. In other words, 3x plus 4 times 3x plus 4. What I'm going to do is take the square root of both sides. And I get just 3x plus 4, and this equals the square root of 6. Well, wait a minute. Not just the square root of 6. Plus or minus the square root of 6. We have two answers. My next step here is to get x by itself. So subtract 4 from both sides. And here's what I have. 3x equals negative 4 plus or minus the square root of 6. My next step is to divide both sides by 3. So I get x equals negative 4 plus or minus the square root of 6 all over 3. And again, that's two solutions. Notice that the method that I just showed you only works when the left-hand side of the equation is a perfect square trinomial. So that doesn't occur very often. So let's find out, how can we make a perfect square trinomial? In this first example, A of example 3, I want you to complete the square, then factor as a perfect square trinomial. So in other words, what number would need to be right here in order for this to be a perfect square trinomial? Now this may take some thought on your part, but I can tell you that there's an easy way to find the answer to this. Look here in this gray box. To complete the square, look at the expression in the form x squared plus bx plus c. You are trying to find c to make the expression a perfect square trinomial. Well, here's what c equals. B over 2 quantity squared. So let's take a look again at this example. B is the 6 in the middle. So off here on the side, let's do c equals 6 over 2 quantity squared. Now 6 over 2 is 3. When you square that, we get 9. So what I want to add here is a 9. And now this does factor as a perfect square trinomial. This factors to x plus 3 quantity squared. Let's try example B. So again, let's take a look at our formula. C equals B, which is negative 12 over 2 quantity squared. Negative 12 over 2 is negative 6. When I square that, I get 36 positive. So let's add 36 here. Now this is a perfect square trinomial, and this factors to x minus 6 quantity squared. My last example is a squared minus 5a. So again, let's use our formula of b over 2 quantity squared. So c equals negative 5 over 2 quantity squared. Wait, this is a fraction and it's not going to simplify. So here's what I want to do. I still want to square it. I square the numerator and I square the denominator, and I get 25 over 4. So what I want to add here is 25 over 4. And you might be wondering how I'm going to factor this as a perfect square trinomial. Remember, this is going to start with a, but what goes here is going to be the square root of this. And the square root of this is 5 over 2. I just look over here for my minus sign, and I have a minus 5 over 2 quantity squared. Now you've learned the foundation for the method of completing the square. I want to walk you through a full example of this. So let's take a look at one that's worked out for you. I have x squared minus 6x plus 2 equals 0. This does not factor. The very first thing you're going to do is you're going to move this 2 to the other side by subtracting it from both sides. Here's what I want to do. I want to leave a blank right here so I can complete the square. And what I'm going to do is come over here to this box and I'm going to complete the square. I'm going to use C equals B over 2 quantity squared. My B is -6, so -6 over 2 quantity squared is -3 quantity squared, which is 9. And that's why I'm adding a 9 to both sides. Remember, what I do to one side, I have to do to the other side. So I want to add 9 to the left, so I must add 9 to the right-hand side. Now, if I go back to the left-hand side, this factors as a perfect square trinomial into x plus 3 quantity squared. On the right-hand side, -2 plus 9 gives me 7. My next step is I want to take the square root of both sides. On the left, this gives me x minus 3. On the right, plus or minus the square root of 7. Add 3 to both sides, so I have x all by itself, and I have x equals 3 plus or minus the square root of 7. The next thing I need to do is put this in my calculator. So 3 plus the square root of 7 is 5.65. 3 minus the square root of 7 is 0.35. And you always want to round to 2 decimal places in this particular class. Let's go through another example, step by step. First thing, this does not factor. X squared minus 12x plus 5 does not factor. So let's move the 5 to the other side. So I'm going to subtract 5 on both sides. This is going to give me x squared minus 12x. I'm going to leave a space. On the right-hand side, I'm going to write my -5. Now, the next thing I want to do is complete the square. And what I mean by that is I want to fill in what would go here to complete the square. So I'm going to go over and use my formula, C equals B over 2 quantity squared. So C equals B, which is -12, over 2 quantity squared. -12 over 2 is -6. Quantity squared equals 36. So what I want to do is add 36 on the left-hand side, but whatever I do on the left, I must also do on the right-hand side. Now on the left-hand side, I'm able to factor as a perfect square trinomial. This is x minus 6 quantity squared. And on the right, I have 31. My next step, take the square root of both sides. On the left-hand side, I'm going to get just x minus 6. On the right-hand side, I'm going to get plus or minus the square root of 31. And the square root of 31 does not simplify. My last step here is to add 6 to both sides, so x is all by itself. And I get x equals 6 plus or minus the square root of 31. Let's do another example. Again, we have a quadratic trinomial that does not factor. So here's what we need to do. First thing, take that 3 and move it to the other side of the equation. And so here's what we have. We have x squared minus 5x, leave a space, equals -3. The next thing we need to do is to figure out what we need to add here to make this a perfect square trinomial. And we're going to use the formula C equals B over 2 quantity squared. So in this case, we've got negative 5 over 2 quantity squared, and this happens to equal 25/4. Now this is not an ideal situation, but fractions are going to happen. So here's what we're going to do. Add 25/4 to both sides. Okay, the next thing we need to do, we now have a perfect square trinomial that we can factor. And again, you're probably wondering, how is this going to factor? Remember, that number on the right is going to be the square root of this number. The square root of this number is right here, negative 5 over 2. So when we factor this, this is x minus 5 over 2 quantity squared. Now we need to change our negative 3 into fourths. So we're going to multiply the top and the bottom by 4. So this becomes negative 12/4 plus 25/4, which is going to give us 13/4. And our next step, take the square root of both sides. So now we have x minus 5 over 2 equals plus or minus the square root of 13 over the square root of 4. But what's the square root of 4? 2. Last step, get the x by itself. Add 5 over 2 to both sides of the equation. And this is convenient because we actually have a common denominator. So x equals 5 over 2 plus or minus the square root of 13 over 2. Another way to write this is 5 plus or minus the square root of 13 all over 2. Our very last example here is different. This is different because in this example, we have a number in front of x squared. And this means we're going to have one extra step. So our very first step in this problem is still the same. We are going to take this 5 and move it to the other side of the equation. So add 5 to both sides of the equation. My next step after adding 5 to both sides of the equation is I need to get rid of the 2. So I have to divide my entire equation by 2. That's going to give me x squared plus 3x on the left and 5 over 2 on the right. My next step is to fill in what I need on the left to complete my square. So I'm going to use c equals b over 2 quantity squared. This is going to give me negative 3 over 2 quantity squared, or I'm sorry, yep, negative 3 over 2 quantity squared. When I square that, I get 9/4. So I've got another fraction. So let's add 9/4 to both sides of the equation. So on the left-hand side, I need to factor this. Remember, when we factor this, the number that's going to be in my factor is the square root of this which is right over here. It's this, negative 3 over 2. So when I factor this, this is going to be x minus 3 over 2 quantity squared. Now on the right-hand side, I need to get a common denominator. So my 5/2, I'm going to multiply the top and the bottom by 2, and that will give me over here 10/4. So I'm going to cancel this out here and write it over here. So 9 plus 10 is 19/4. My next step, take the square root of both sides. On the left-hand side, I have x minus 3 over 2. On the right-hand side, I have plus or minus. On the top, I have the square root of 19. On the bottom, I have the square root of 4, which is just 2. My last step here, I need to add 3 over 2 to both sides of the equation to get x by itself. And that's going to give me x equals 3 over 2 plus or minus the square root of 19 over 2. Another way I can write that is 3 plus or minus the square root of 19 all over 2.